Let's do this problem without doing constrained loops at all. We'll define 3 mesh loops in the non-overlapping areas. So I'll have one non-overlapping area here. So I1, I'll have a mesh current I2 here, and I'll have a mesh current I3 over here. Now I just charge in and start writing KVL. So for loop 1, minus 12 volts plus 3 ohms times I1 plus this loop goes through this 2 amp source. I don't know anything about the voltage across that 2 amp source, so I have to define that as an unknown. Let's make that V sub S with that assumed polarity. So now I see the positive terminal of V sub S first. Now I see the 3 ohm resistor. So 3 ohms times I1 minus I2 is equal to 0 for loop 2. I have 1 ohm. I2 is the only current going through that resistor. Now I use this same definition for V sub S. So minus V sub S. V sub S isn't chosen according to Ohm's law, so I have to pick a polarity and stick with it. That brings me back to my starting point, so that equals 0. And finally for loop 3, I have my 3 ohm resistor times I3 minus I1 plus 6 ohms times just I3 plus 6 volts is equal to 0. Now let me write my equation for V. V is equal to 3 ohms times I1 enters the positive terminal, I3 enters the negative terminal, and that gives me 4 equations, but in 5 unknowns. With this approach, I introduced another unknown V sub S, so I need to write another equation. What I do know is that the sum of the mesh currents through any element has to equal the physical current through that element. The current through the 2 amp source is known. That becomes a constraint. The mesh currents that go through that 2 amp source are constrained by that current. So we have to write what is called a constraint equation so that the 2 amps is equal to the sum of the mesh currents through that element, keeping track of the signs. So I1 is in the same direction as 2 amps, so 2 amps is equal to I1 minus I2 since it's going in the opposite direction. That gives us our 5th equation in 5 unknowns. We can solve those equations for V.